Welcome back, everyone. In today's video, we'll be looking at how to evaluate this question. Given the function g of x equals to 2x squared minus 32 all over 3x squared minus 9x minus 12, for x cannot be 4, define g of 4 so that g of x is continuous at x equals to 4. Here are our choices. So let's remember, how do we define continuity? So a function g of x can only be continuous at x equals 4 if and only if the limit of x approaches 4 of g of x is the same thing as g of 4. Okay? But since g of 4 is undefined, right? You can't plug in a 4 directly in here because it's not a part of our domain. Okay? And we'll see that as we work through this problem. We need to use limit to help us out. So let's take a look at this function. Okay? So we have 2x squared minus 32 all over 3x squared minus 9x minus 12. Okay? The best way to evaluate one of these problems is by factoring. So we want to factor as much as we can. So let's factor the numerator and the denominator. So let's factor out a 2 in the numerator. So we have x squared minus 16. And then in the denominator, each of the terms are a multiple of 3. So I'm going to factor out a 3. So we have x squared minus 3x minus 4 in the denominator. Okay. Now, if you take a look at this, you can see that the numerator and denominator can still be factored. So let's go and do that. So on the numerator, we have 2, and then we have a difference of 2 perfect squares. So this would be x plus 4, and then x minus 4. Okay. And in the denominator, we have our 3, and then we have our factoring here. Okay. We can factor what multiplies to negative 4 and adds to negative 3. So we have x minus 4 and then x plus 1. Okay. Now we can see why x cannot be 4, because if you plugged in a 4 here directly, we would get a 0 in the denominator, and 0 times anything would be a 0. So now we can cancel this out. Okay. We can cancel out the x minus 4. And then we have, let's just rewrite what we have left. So we have 2 x plus 4 and 3 x plus 1 times x plus 1. Now that we clean this all up, we can bring in our limit. Okay, we can bring in our limit value so that we can substitute directly and figure out what value x equals 4 has to be in order for g of x to be continuous. So we can say limit as x approaches 4, and we can just do a direct substitution in here because there's nothing that would make a 0 in the denominator. So we have 2 times 4 plus 4, and then we have 3, 4 plus 1. Okay. This would be 2 times 8, and then 3 times 5. Okay. Now we have 2 times 8, which is 16, and 3 times 5 is 15. Okay. So what we want is that we want g of 4 to equal to 16 over 15 in order for g of x to be continuous, okay, at x equals to 4. And taking a look at our choices, okay, we have g of 4 equals 16 over 15, And the answer is C. Hope that helped. Feel free to leave a comment about what topics you would like to see me cover, and I'll see you in the next video.